All right, guys. Go-kart. Well, if you want to call it a go-kart. I don't know what you want to call it. Buggy, go-kart, cross-kart. This will be part one of this build. We're gonna talk about it, talk about the plans that I have for it, kind of what I'm thinking. Got some cool ideas to do on this one, that are gonna be pretty innovative. I mean, there's been some other sports, Formula One, a few other people, engineers have done things like this before, which I'm going to show you in a minute. But I have some pretty cool ideas. So let's go in the shop. It is a working shop right now, so there's noises. Hopefully the audio will be okay. Might have to do a mic at some time. But anyway, let's go in the shop. I'm going to show you kind of what I've got, what I'm thinking, and let's go from there. All right, so one of the first steps I want to do here on this new build is figure out the rear suspension, rear axle, rear drive, all that stuff. Many different ways of doing this. A lot of guys are using like Mazda Miata axles and half shafts and unit bearings and stuff, which is great. I mean, it's a cheap option and very user friendly. You can kind of buy those parts from the parts store and put something together. These parts here, so this is like a half-ton Chevy unit bearing here, which a lot of the sand cars, from what I understand, I'm no expert, but I'm learning. But I guess some of the sand car guys are using these. Then they also buy this 33 spline. It's called a super stub axle that goes into that unit bearing, and then from there, that's not in all the way, but a little tight. But then from there, you would bolt this 930 CV to that, and then from there, obviously your wheel is out here, wheel and tire, right? So that's at one end. Then you'd have an axle shaft. I'll have the balls fall out here. Then you'd have an axle shaft that would spline into that, and then from there you would have at the diff, you'd have another 930 CV. Turn the camera here. There we go. You'd have another 930 CV at the diff side, at the center, that would be bolted to some kind of an axle, and then on this axle or this shaft you would have a chain drive spool, basically a sprocket here, that would run up to your motor. So all this would work. You could put this all together. You could build an upright or a spindle that would hold the unit bearing and hold all these parts in place and do all that. All this would work. But there's some things about this that I don't like, and I think we can improve on. Also, I think we can maybe save a little weight. Maybe I'm not that concerned about that, but there could be a possible weight savings there. And this is what that is. So you have multiple parts to make up one, there's multiple pieces here to do one thing. And anytime you can get rid of some parts and combine some things and have one thing do multiple things, I think that's pretty cool. And kind of simplify the whole process. So this is what I'm thinking. All right, so this is what I'm thinking. So we have this 930 CV here, okay? What if, instead of running this big unit bearing right here, what if I took this big bearing? So I found these bearings, actually, well, I found them online, but then I ended up finding some on eBay. They're big, I don't know, like 7 inches across with like a 4.33 center. This isn't even actually the one I'm going to use. This is actually small, but it fits around this CV, right? So what if, instead of all this right here, let me get you in frame here, all this stack up of parts, this, and this, what if got rid of that and just did that right there? That's it. So this is my thoughts. So we take the CV, I machine an adapter, basically a wheel adapter that would utilize these 6 bolts. It's probably about 1 inch thick, and it's going to basically convert this 6 bolt pattern to a wheel lug pattern. So go from here to a lug pattern, so a flange, the actual wheel and tire bolt on to this right here. At the wheel end, I'd probably run 2 bearings, so probably have something like that. So you have two bearings to support the load, you know, the vehicle, and then from there, axle slides in. There you go. So that's at the wheel hub. So that is replacing that. You can see the difference that is. You can see how much. Well, it'd be a little shorter than that, but you're probably saving 3-4 inches of distance of stack up for that, you know. So and then the same thing at the diff side. So at this end, so same deal. You got the CV, splines on this axle. We got a bearing. So at this end, a little different. Let's shift everything over here so you can see what we're looking at here. So at this end, you would have 2 CVs here. They would have a little gap here because you got to have a little space here for the axle to plunge. So this axle goes in and out, plunges in all this as the suspension travels through its arc. This axle shaft actually goes in and out some. So you got to have a little bit of, you know, you got to have a little bit of room for that to happen. But so you got 2 CVs, 1 axle going out to the right wheel, 1 going to the left wheel. And then same as at the wheel end, we have a bearing here. Things aren't wanting to stand up here, but you got a bearing there and you got a bearing here. So that is the width right there of the differential, which is like, I don't know, 4 inches wide. Normally, like on a rear diff, you'd end up having, after everything is stacked up, after you have some kind of a flange to bolt a CV to, you know, after you have this, then you have some kind of a bearing, then you have a sprocket, then you have another bearing, then you'd have another flange, and then you have another CV. You know, you're talking something that looks like that. You know, what is that? That's probably that's like 8 inches, something like that. Versus this. That's it, 4 inches. So there you go. So the combination of having this super narrow diff. So at this diff, I'll have a sprocket to run up to the motor. On this side, I have another flange to bolt a brake rotor to, which all of this stuff would be outside, you know, of the flange. So you'd have the brake rotor, you'd have a sprocket, but it'd all be within this 4-inch width. So between that 4 inches and then the amount of weight, and then at the wheel end you got that much. So you're probably adding, I don't know, 4 to 6 inches of axle length and arm length to the rear suspension. So the reason you want to do that, why do you want to narrow this up and shorten this up? What would be the reasons to do that? Well, the main reason that you want to do that anytime when you're building suspension, especially like, well, any suspension, but especially independent suspension, the longer you can make things, the better. So the longer this axle is, the better. The longer these A-arms, the better. So a couple reasons for that is the longer, let's move some stuff here. The longer this is, the more travel you can have with less angle. And the less angle means the longer this CV will survive. And so I'm shooting for something with a ton of travel. So I want to have a lot of, you know, I want to have a long suspension parts so I can have less angle and lots of travel. So that's my goal. So that's kind of what we're looking at. I've started to CAD this up in Fusion 360 a little bit. Some of the parts here, I've got already drawn some of it up, and I could take you over there and kind of show you kind of what we're going on. So that's my plan. So we're gonna do these crazy big bearings, CVs, wheel adapter, cool billet, aluminum upright, you know, suspension parts. I think it's been pretty cool, and I haven't really seen it done before, really. I mean, you know, Indy cars, you know, IndyCar, Formula One, they've done some things like that. There's a, you know, anyway, I've seen a few examples of this. You know, I thought, you know, buying a bearing big enough to go around a CV, I figured that bearing would be like unobtainium, you know, like super hard to get. But a quick search last week, I actually found an SKF bearing that was that size. And then after, you know, you hop on eBay or whatever, and, you know, I think I bought one of these bearings for like 20 bucks. So, which from SKF is like $400. So, you know, eBay is the best source for this stuff. You know, you can buy a lot of old, like new old stock. You know, like that's one of the boxes, you know, it's been sitting on a shelf for the last 20 years, whatever. So I've got a few of these bearings now that came in here this last week. And so yeah, so I'm pretty excited about this. This is gonna be pretty cool. So it should be a cool, cool project. All right, here we go, guys. So try to explain to you guys what I'm talking about a little bit better here on Fusion here. But so here you can see here, I've got a BFG here, cut in half. Got a wheel here, cut in half. This is a 15-inch wheel. Actually started out as a method wheel that I modified. I don't know if you guys, you know, I'm pretty new to CAD. You know, it's probably been the last couple of years now that I've kind of started to learn it. When I bought the Fadal, you know, CNC, you kind of have to learn it, you know, if you want to be able to program. Anyway, it's been a super handy tool to have. You know, in the past, it's always been cardboard and just lay it out the best you can, figure it out, you know, kind of in space. It's been really neat to be able to do this on a computer first, and definitely helps you design kind of what you're making a lot more precise, and even, you know, you can even add a lot more cool factor to it too. But all this stuff, this BFG tire, this method wheel, even these bearings, I found all those models online. So if you go here to like GrabCAD, you see there, so you can go on this website called GrabCAD and search, and they pretty much have I mean, they have so many different things. Like there's a BFG tire, you know, a lot of different options. All this stuff, you can just grab it, download it, and just pull it into all right, anyway, so that, yeah, GrabCAD, super handy tool to have. Also, these bearings, SKF bearings, those big bearings that I showed you, you go to the SKF website, download the model, so pull it in. So there you go. Pretty cool. So anyway, so we got this BFG tire here. We got this 15-inch wheel here. We have the two bearings. Got one here on the left, one on the right. If you look inside here, we have the 930 CV. You see there? That's the CV, the outer race of that CV. So. So kind of what I talked about there. So, and then on the outside here, if you look, we have basically this adapter piece. So let's turn off some stuff here so we can see kind of what we're talking about. So if I get rid of those bearings, you can see here, and then if I turn off, let me get to it here. If you look at this, here, let me turn the wheel off as well. There we go. So there's the wheel off. So if you see here, let me turn off some sketches here. There we go. All right, there we go. So basically, what I need to make is, to make this all work, is I need to make this hub. So you can see that the CV housing is inside of this hub. I could turn that off too. So pretty much what's going to happen is this hub here, the CV will slide inside. Okay. So and it'll probably be it won't be a press fit, but it'll be a good fit. It'll be able to slide right up in there. That CV will bolt into the hub. It'll also have this dished out area here for the axle plunge to go in and out. You gotta have that. Okay, so that'll hold the CV, and then the outer here, that'll hold the big bearings, right? And then on the outside here, lug nuts or the studs will come through, and your wheel will bolt on. So there you go, yeah. So then you got this hub here. This is a functioning shop. So, you know, I've got loud machinery all around me. So, you know, it's whatever. You know, I'll have to cut it. I'll have to cut and splice this video to, you know, hopefully we can hear each other. But anyway, got this hub here. Got your wheel studs would come through that hub. Your wheel will bolt on. So basically, we can measure now. What is this overall stack up going to be here? So if I measure this from this front face to this rear face is 3.2. So 3 inches 200. So basically 3 1/4 is the thickness of that hub. Versus what we saw on the table, a unit bearing, that stub axle that would be through there, plus a CV, then the axle. So you're probably talking 6 to 8 inches worth of stuff, you know, before the axle gets to be part of it. So that's the difference here. We can go from 8 inches roughly of distance down to 3 inches. That means we can lengthen that axle shaft, you know, overall probably 6 inches, which is a lot per side. That's like 12 inches overall, which is pretty amazing. That's going to equate to a ton more travel and a lot less angle on components. So that's why it's pretty cool. This is kind of exciting. This is the kind of stuff that really gets me kind of I don't know, it kind of gets me going here. So it's pretty cool. So anyway, so that's what I'm working on. So what I need to do is I've roughly kind of got this hub figured out. This, you know, I'm trying to use some Can-Am parts for this, so I can, you know, I'm trying to, you know, budget and expense is always part of the equation here. So this right now is a 4 on 137 millimeter bolt pattern, which is Can-Am, like a Maverick X3 Can-Am. From what I understand, I've never owned a UTV, so I don't know all the ins and outs, but that's what this is designed for. I originally was going to run some, I actually have some Polaris Pro R wheels, which is a 5-lug. That's kind of what I was originally going to use, just because I already have some wheels for that. But, you know, this 6-bolt and 4-bolt pattern kind of need to nest together. Yeah, so we got this back together here. So yeah, so we have that center hub, we have a bearing, and then we also have this retaining ring here that bolts on, basically to hold the bearings, you know, on the hub. And then between the bearings here, we would have a like a 1/4 inch, you know, a 1/4 inch spacer to keep the bearings, you know, separate. So the next things that I'm working on then from here is I kind of have that dialed in. Let's put the wheel back in. So the next things we need to do here. So if you look at this, so inside here now we need to make an upright, basically a spindle upright, basically something that surrounds the bearings that your suspension points can bolt to. So that's the next thing. So there's some considerations there. You kind of need to keep in mind. Obviously, I want to get these pickup points, the pivot points for the A-arms, you know, the suspension arms here, A-arms. I want them to be as far outward as possible. There again, I want to make those A-arms as long as I can. And so there's some limitations there. Obviously, let's see here, let me see if I can turn my sketch back on from earlier. So I got a little sketch here. Maybe hope you guys can kind of see it on the screen there. But so this point and this point are both just rough pivot points for the upper A-arms. So there's a lot that goes into, I mean, this is rear suspension we're talking about here. So, you know, there's scrub radius, geometry that you need to consider when designing front suspension, rear suspension, and I'm no engineer and I'm no suspension expert. I just know what I've learned over the last few, you know, last years and what I've learned off the internet. So, you know, I'm not an expert here, and I'm sure I'm sure I'll get some comments, you know, down below that tell me that I'm wrong, and that's fine. I can be totally wrong here. I'm no expert. The reason I'm doing this stuff and the reason I get excited about this stuff is I'm doing things I've never done before, and I love learning new things. I don't like doing things twice. So what I'm doing here is something I've never done before, and I've never actually even done rear independent suspension. I've done front independent suspension, never rear. So, you know, I'm learning as I go here. And so, yeah, if you guys have some suggestions on things, yeah, comment below, you know, help me out. But anyway, these 2 points here, that's kind of my upper and lower pivot point, you know, roughly right now. This is all just, I'm just doing a sketch here, trying to figure out where I want to put things. But, you know, I want these to be as close outward as possible so I can get these A-arms, these control arms as long as possible. But part of the problems with that is, you know, here, let's go here, let's see here, let me get back to here, let's go here, forgive me for if I go here and edit my sketch here, I can play around here with this a little bit. But you know, as your suspension travels, obviously this is an AR moving up and down. You know, there's some limitations here. So the further this pivot point is out, the less angle I can get before it, you know, wants to hit the wheel. Like that's the actual wheel right there. If I orbit this a little bit, you can kind of see, you know, that's a limitation right there. You know, the wheel's right there. You got an A-arm coming through here. So those are some of the things. You don't really know, I won't really know any of that stuff until I can kind of get things modeled up to a point where I have my lengths where I want them, and then I can cycle the suspension and see where that's going to hit. I think I am going to raise this pivot point up a little more. I think I'm going to raise it up. It'll give me a little more ground clearance. But I want to have, you know, as much separation between these points as I can to help with just, it'll help support the load better if these are spread apart. So it's kind of a give and take. You want to have ground clearance, but you also want to have strength too. So it's a give and take. So that's what I'm working on now. I need to make an upright for these pivot points, you know, and then the upright will also, you know, give you your 2 pivot points for your suspension pickups here, and then it'll also come around and, you know, hold those bearings on the outer race. And then I also need to do a like a tie rod, basically that'll go to the chassis to keep this, you know, especially on the rear, to keep this thing from wanting to steer on me. So, and then I'll also be able to set my toe on the rear and that sort of thing. So that's kind of what I'm doing next here, is trying to design my, what you would call an upright, you know. So that's what I'm doing. So I hope that made sense. So a little long-winded there, trying to describe, you know, what I'm doing. Kind of, I don't know, kind of complicated, not really. You know, I hope this is informational. We can kind of learn together here. Like I said, I'm no expert at this. I'm learning as I go. But it's fun to build some things here that aren't just off the shelf. You know, we can engineer, create, make something unique, and also make something that's going to be better than what you can just buy. You know, we've got the CNC mill, we have lathes, we have the equipment here to make stuff. So let's do it. You know, so that's what I'm doing. I'm gonna get to work designing this upright. That'll be billet aluminum. The center hub that I was showing you, that'll probably be steel. I think that needs to be steel to support the load of all that. But that's what we're doing. Stay tuned. This will be kind of part 1 of this build series. I plan to take you guys along on this. If you would, you know, like and subscribe, all that stuff. Leave comments. There's a lot of technical stuff happening here. If that's what you're into, then this is going to be the perfect build for you. So very technical stuff here. Need to the bearings for the kids go-kart. There might be some overlap between videos here because I'm doing a little video. I ruined a bearing on the jack shaft on the kids go-kart. So that came in here this week, so we can throw the bearings back in that thing, get that thing up and running, and kind of go from there. So hope you liked it. I'm gonna set the camera up here while I do a little time lapse designing the uprights, and then that's it. So this will be part 1. So then part 2, hopefully like next week or whatever, part 2 would be actually getting these parts finalized, get the cam set up on it, get the tool paths, and we can actually maybe start making some of these parts in the mill here. So it's going to be a cool project. It's going to be a go-kart / UTV, somewhere in between there, buggy, whatever you want to call it. Got a Yamaha R1 motor out in the trailer. I think this can be cool. So also have laying around some of these are Can-Am, these are kind of like leftover coilovers from the project here. So I don't even know what that travel is. What is it, 8 inches or something? But it's a 2.5 inch coilover. I mean, it's a beefy coilover. So I'm planning to use these shocks for this build. So, you know, I'm planning to build something that has a ton of travel. So we should be able to jump it, you know, like send it, you know, but also handle well. So goal would be to have somewhat of Swiss Army knife of a few different things. Off-road, maybe take it to the road course, to an actual track, and put some slicks on it and run it on a track, and then possibly even make it street legal. I don't know. In North Carolina, you can drive a UTV on the street. So I thought, well, maybe, you know, it'd be kind of cool to be able to drive it on the road. So that's kind of what my thoughts are. So anyway, after all that talking, stay tuned for the next video. It's gonna be sweet. We'll actually, like I said, hopefully we'll be able to make some parts and start putting some stuff together. So, all right guys, catch you on the next one. See ya.